Okay, hi. My name is Levi Rybalov. I'm the founder of Co-op Hive, and today I'm going to be talking about multi-agent systems and Filecoin. So what is a multi-agent system? So a multi-agent system is a system composed of interacting intelligent agents. And so what are agents? Agents are autonomous. They are, for the most part, in this context, they're going to be like, you can imagine them being scripts that make automatic decisions without human inputs, right? So they're independent. They are cooperative. Agents can cooperate with each other to achieve larger goals or compete with each other, for example, like in a marketplace. And they're distributed, right? So in this context, they're distributed across the network. In the Filecoin network, you can imagine like every node in the Filecoin network being an agent, but you could also imagine those nodes running many different like LLMs and so on, and those being agents. So there's many different ways to think about how agents would be acting in the Filecoin ecosystem, and there are many different ways to enact them. Again, you could have it on a data center level, on a node level, on an LLM level. You can chop up resources on machines and have each of those be agents and so on. The key points of this talk about what multi-agent systems bring to Filecoin are that they help create more efficient markets. They are going to probably be the primary producers and consumers of data. Already, it's kind of a meme, but autonomous agents are going to be the drivers of most economic activity in the future, and likewise, they'll probably be the primary users and consumers of data and storage. Coordinating agents can help achieve larger collective goals on like a protocol level. Okay. So what are the impacts on the market? So first is this concept we want to cover of utility maximization, which is this concept from game theory that every agent or player in the game has like a utility curve, and then a utility function, and then it's basically like the function of the input. The utility equals some kind of function of the input, and you want to maximize the utility. In real life, humans are not utility maximizing because they don't make perfect decisions, and they don't really know what they want, and all these kinds of things. But machines can actually be somewhat trained to act in a utility maximizing manner. So for example, to kind of the TLDR of it is if you look at the AIs that beat chess, humans at chess or Go or poker, all of those agents were trained to maximize utility. And so what can these autonomous agents do with each other? So first they can do peer-to-peer negotiation over the pricing of jobs, right? So when you have like a lot of agents interacting with each other on the buy side and the sell side, and they can actually find better price points that actually reflect the supply and demand on the network. They can predict future storage needs based on historical data. So right now, a lot of data on Filecoin is archival, but as we just saw in the previous talk, once we get things like hot storage up, once we get things like IPC kind of robustly operating, we're going to have like much smaller data sets that are going to be much shorter lived. And you're going to need a lot of dynamic management for that. And the best way to do that is the best way to manage those resources are going to be autonomous agents, at least for now. Maybe we'll have new paradigms in the future. And so, of course, they can do other things like optimize data placement to reduce latency. Again, right now we do this usually using scripts and some kind of like either some traditional algorithms or it could be like genetic algorithms or whatever it might be, but kind of agentic approaches where this agent really is trying to maximize utility on behalf of its owner. That paradigm is really going to shift things like the challenges around optimizing that data placement for both to reduce latency, to reduce storage costs, and so on. And then autonomous maintenance will lead to self-healing networks, right? So when some kind of replica drops off the network and you definitely want another replica back up and running as quickly as possible, in this we'll see in a coming slide, agents operate 24/7, right? And so they're going to be the first responders to those kinds of emergencies, and they're going to get the data back up in the next best place as quickly as possible. And so in the end, that basically means that we're just making better use of existing resources at the end of the day. When you have these agents, again, acting in a utility maximizing manner to bring the most benefit to the people that own them, and that could be either clients or storage providers or other players in the network, ecosystem actors, and so on, it just makes better use of what we have on the network. So the agents are going to be users of this network as well, right? So the main reasons for this are, one, that they're going to be operating 24/7. Agents never fall asleep. They are always working. They don't take vacations. They don't go to offsites. They are always on point, and they're always getting things done. And so they would be doing things like monitoring network conditions, adjusting the storage strategies, executing, and they can, of course, they can execute transactions at any time, right? So that's a kind of critical fact, right? So if you have some kind of, again, replica drop off the network, you need another replica back up and running immediately. If this autonomous agent has access to a wallet, well, it can get a replica back up and running in like the place that reduces cost and latency as quickly as possible. They can, of course, easily consume and produce massive amounts of data, right? So you could just imagine, and I'll give some examples in the next slide, but basically you could imagine, ingesting some, massive environmental data, let's say environmental data set like satellite data, right? So you have like these massive, like image data sets that need to be processed on like a daily or an hourly basis for like environmental climate change prediction or weather prediction or whatever it might be. They're consuming enormous amounts of data when they do that, but they're also going to be producing enormous amounts of data as well, right? And so they are going to be producing and consuming enormous amounts of data in storage, and they need, of course, a place to store that data in that process. Of course, the coordination of agents can help lead to achieving much larger kind of collective goals, right? So just to give an example, you can imagine a bunch of agents trying to do a distributed extract, transform, load task across many different nodes across the world, they do that collectively. They all each have their own local data sets that they did, maybe some kind of compute over data, using some compute over data solution, and then they can automatically upload that data to Filecoin, right? And then of course, once that data has been uploaded to Filecoin, well, they have all of this historical data about who accessed that data in the past. And so they can kind of use kind of a collaborative filtering to actually recommend where to recommend to clients, or like look for clients for that data, basically. And of course, another benefit is like scalability, right? So humans can only do so much by themselves, right now we usually rely on software to manage a lot of the things that have been described here in the last slide and in the next slide. And really, agents are just the next paradigm, the next version of that kind of software. And the real kind of mentality shift, is that these agents are going to be maximizing utility. That's really kind of like the core difference between a lot of the prior approaches and what these agents are going to be doing. So just to give us some example, federated learning and collaborative filtering. So something where you need to ingest a lot of data from a lot of different actors in the network, and like do some kind of function over it and output the result. That's a lot of that's going to be done by autonomous agents. They're probably going to be ingesting a lot of data when they do that, depending on the application. Coordinating logistics, and inventory management. So supply chain management, right? You're going to have these supply chains all over the world. Like these objects going through these really complicated routes, shipping routes, manufacturing processes, and so on. And these agents can be coordinating with each other, ingesting the data. Where is that object being created? Where are the raw materials coming from? How is it going to be shipped? And they can, optimize the transmission of that, again, because they're acting in a manner that's supposed to maximize the benefit to their owners. So peer-to-peer energy trading, which would lead to energy efficiency, right? So this is another kind of a classic example that we're going to be seeing more and more especially as we have more distributed energy resources on like solar panels, windmills, batteries, and so on. These agents are going to be like negotiating with each other over where to send the energy and where to store it. Again, that's going to consume probably not as much data as some of these other things, but a bit. Then of course there's like sensor coordination. So you could imagine for weather forecasting, WeatherXM is a great example of this. That basically you have like a bunch of data being ingested from different, all these sensors all around the world. They're all collecting like temperature and humidity and pressure and all this data from the environment. They're doing some kind of computation over it, and they have to send it somewhere. They have to send it to the agent that needs it the most. It could be some kind of central node which is aggregating it. It could be like some other node somewhere else to like double cross-reference check, whatever it might be. And then, of course, location-based services like decentralized vehicle routing. That's kind of a personal favorite of mine. But basically, anything that involves like mobile user data, data that's stored on people's phones about like where they walked that day, and like we have these things already, like how crowded is the train, how crowded is the New York City subway, how crowded Waze, or Google Maps, how crowded is this road, how bad is the traffic, and so on. And so a lot of this data needs to be stored somewhere and used, consumed, produced, etc. And the last major benefit, rather major impact that it's going to have on things like Filecoin is going to be the long-term crypto economic planning of Filecoin. So multi-agent systems are going to improve long-term planning by aligning agent incentives with network goals, right? So just to give an example of this, Filecoin, one of the objective functions of Filecoin's reward structure is to drive the price of public storage down to zero, right? It stores all of these public data sets and tries to make them freely available, storing all of humanity's most important information. And we can use learnings from things like mechanism design and multi-agent reinforcement learning to direct these agents to do that in the most efficient manner. And that can come in a number of different ways. It could be by aggregating information from the internet about like what is the most valuable thing to store. It could be like currently, like what current event is happening right now that requires a ton of data, or maybe the most valuable public storage of data sets is going to be outputs from like simulations from the Large Hadron Collider or something. So these multi-agent systems are going to be teaching us a lot about what the most valuable use of those resources are. And of course, storage providers, another network goal of naturally is to get high availability and reliability and low cost, right? And so, of course, storage providers are going to be incentivized to offer competitive prices and maintain high availability, and consumers of the data are going to benefit from reliable and cost-effective storage solutions, right? And a lot of this is going to, again, be mediated by autonomous agents, again, because they are being trained to maximize utility on behalf of their owners, on behalf of consumers, on behalf of providers. That high availability, low cost is a protocol level goal of the network, right? It's a protocol level goal of Filecoin, and so we can these multi-agent systems are going to teach us a lot about how to do that. In conclusion, so autonomous agents are really going to dramatically enhance Filecoin and have a massive impact on it by becoming its primary users. That's one major factor, but also by improving the market efficiency, teaching us a lot about the long-term economic planning, and improving network reliability. And the second kind of key takeaway is that storage platforms that prepare themselves for this pretty much inevitable future are more likely to succeed than those that don't. And so we should be seriously planning for the future, for the autonomous future. Thank you.